For this activity, we are given 3 sets of data and asked whether they're linear, exponential, or neither. So you can see I'm over at Desmos, and what I'm going to do is graph them, try to draw a preliminary conclusion, look at the data, make sure we get the right kind of data, and then when we're all done, we're going to go run back to the little whiteboard and then trying to find the equations of everything we can. So let's just turn this first set of data on first, and I'm going to make sure we zoom fit the data so it looks pretty. That looks exponential. It looks like it has an asymptote to the left. It looks like it's going off to the right. So I'm just going to make a little note to myself and say, note, this first function looks exponential. That's not a check. We'll come back and check. Just a note to myself. All right, I'm going to shut those points off. I'm going to go to the next points, and I'm going to graph that. Aha! You can see that this graph goes up and then comes back down. Linear functions can never go up and then come back down. Exponential functions can never go up and then back down. So this is actually definitive for this one. This function is absolutely guaranteed not linear nor exponential, since it goes up and then it comes back down. Now, for what it's worth, it might be quadratic, but I don't think they asked that, so I'm not going to fuss about it for now. All right, I'm going to shut this data off. Let's look at the last set of data they gave us. Let's turn it on, and then I'm going to plot it, and that looks nearly linear. I'm going to say that, then we'll double check it. I'm just going to put a little note in here. This data could be linear. All right, now we've made preliminary decisions about each, although the second one is guaranteed to be right. Let's go back to the first one. In order to see if this is exponential, what we need to know is that if I take each number and divide by the previous number, do I get the same answer each time? So what I'm going to do is add an extra column. I'm going to call this extra column R, because I just want to take each one and divide by the previous one. I'm going to use the next line as a little calculator just so I can do this. I know I want this to be 0.2 divided by 0.04, and you can see that's 5. The next calculation I want to make is I want 1 divided by 0.2, and sure enough that's also 5. And the next two are real easy. 5 divided by 1 is 5. 25 divided by 5 is 5. Not only does this one look exponential, since all the common ratios of successive terms, how about y values, is 5. This is exponential data. So we know now that it's exponential. It doesn't help us with the equation, but we do know it's exponential. Now I'm going to go back to the last one, turn off my exponential data, go back to what might be linear data, and what I want to do is just make an extra row like we did before. I'm sorry, an extra column. I'm going to call these D for differences, and what I want to do is take each y value and subtract the previous one. And I want to use this extra little row right here for the calculator. So what I want to do, I want 200 minus 460. I think that's minus 260. And that's fine. For the next one, I'm going to take minus 60 minus 200, and that's minus 260. Now, by the way, if I even once don't get the right answer, the same answer, it's not linear. Minus 320 minus a minus 60. There's minus 260. And finally, let's check the last one. Oops, you booger. Now I want that to be 4. Here we go, and 7. And this is 580. This is ridiculous. All right, here we go, finally. It's too fast for me. I want minus 580 minus a minus 320. And it's again minus 260. Now, since all the differences were the same, this is guaranteed to be linear data. Actually, all the differences of successive y values, that just means one after the other, were the same. So this data is guaranteed to be linear. So we know the first one's exponential, we don't have an equation. We know the second one is neither, and we know the third one is linear, but we don't have an equation. So what we're going to do now is stop here and then go find the equations.